Hello friends, here's another question on Lami's theorem which is generally asked in exams. The question goes like this. Two rollers of same diameter are supported by an inclined plane and a vertical wall. The weight of lower roller is 250 Newton and the upper is 200 Newton. We need to find the reaction force A, B, C, D. So, we first take the upper roller. The various forces for the upper roller is like this. It goes something like this. For the upper roller, the forces is the weight of the roller, this inclined plane reaction C, which is perpendicular to the inclined plane, and this pressure RD to the lower roller. So we resolve it. It's like this, where this is RD due to the lower roller, this RC acting perpendicular to the inclined plane, and the weight W2. So we now apply Lami's theorem. Like I have told previously, Lami's theorem states that if a body is in equilibrium under the action of three forces, then each force is proportional to the sine of angle between the other two forces. In this case, let me take the RD force first. For RD, the other two forces is RC and W2. So, for RD, according to Lami's theorem, RD should be proportional to the sine of angle between the other two forces, which is RC and W2. So, we will take this angle. Now this angle is 180 minus 15 degree. This 15 degree comes from this 15 inclined plane angle 15 degree, since for this and this these both triangles are similar by similar angle property. So this angle becomes 15 degree. So since this is a straight line, this entire angle becomes 180 minus 15. So RD should be proportional to the sine of angle 180 minus 15. Now for RC should be proportional to the sine of angle between the other two forces RD and W2. So since it is a perpendicular, so it is 90 degree and this is 15 plus 90 degree. So it becomes sine 90 plus 15. Now the weight should be proportional to the sine of angle between the other two, that is RC and RD, since both are perpendicular to each other, so it becomes sine 90 degree. Now we have to just find the value by equating the equation. Now we take this equation and this equation, so it becomes RD is equal to W into sine 165, which is 180 minus 15, upon sine 90. So it is 200. Since it is given in the question, 200 into 0.2588 upon 1, which becomes 51.76 Newton. Now we find the value of RC by equating these two equations. RC is equal to W into sine 90 plus 15, that is 105 upon sine 90. Weight is 200 into 0.9659 upon 1, which is 193.18 Newton. So we get the values for RC and RD. Now we need to find the other two values of RA and RB, which we will find for the lower roller. For the lower roller, we have four forces. This due to the vertical wall, this due to the inclined plane, this weight W1, and this pressure due to the upper roller, this at contact point D. So we have four forces which can be resolved like this. Yeah, this is RA due to the vertical wall, this is RD due to that upper roller, this weight acting downward W1, and this RB, that is due to the inclined plane. So here in this case we cannot apply Lami's theorem, since here we have four forces and Lami's theorem is valid only for three forces. So we have to solve this by equating the horizontal and vertical components since the entire system is in equilibrium. So for this array, this angle becomes 15 degree again due to similar triangles. So this we resolve the horizontal and vertical component for array since the arrow for array is incoming, so it becomes array cos 15. The arrow direction is very important to verify the signs and hence the values, whether it is negative or positive. So this becomes array cos 15 and this becomes array sin 15. This is cos 15 because this is the base. This angle this is cos 15 because this is 15 and this is the base on which this 15 is made. So this is cos 15 and the other is sine. Now for weight, similarly the arrow is outgoing, so it should be our arrow pointing in outward direction. This is again due to its base is on this, so it is W cos 15 and this is W sin 15. This RD is acting horizontally and this RB vertically, so we need not resolve them. Now resolving in horizontal direction, this one, taking right going arrows to be positive and left going to be negative, we get RA cos 15 minus W1 sin 15 minus RD equal to 0 since it is in equilibrium. Putting the value of cos 15, 0.966 minus weight which is given in the question 250 into 0.259 minus RD 51.76, which we have calculated here. This RD we just have put its value here. So RA gets to be 116.51 upon 0.966, which is 120.61 Newton. Now in vertical direction, taking upward going arrows to be positive and downward to be negative, we get RB minus RA sin 15 minus W cos 15 equal to 0. So RB equates to RA sin 15 plus W1 cos 15. Putting the values of this RA from here, sin 15 and weight which is given in the question and cos 15, we get RB to be 31.21 plus 241.47, which equals to 272.68 Newton. So we get the value of RB, RA and RB here. So we get the values for all three reactions. Hence we have solved the question. Now we will take further concepts in the next video. Thank you.